It's me again, Miss Kayanan. We will be studying a little more about elements and compounds, symbols, and formulas. So, what is an element? Earlier, I said that element is a pure substance that cannot be further broken down. Element is made up of one type of atom only. For example, we've got hydrogen, and we also have hydrogen gas, which is made up of two same atom of hydrogen. And then we also have oxygen, and oxygen gas is also considered an element because it is made up of one type of atom. In the same manner, nitrogen, as it is an element, but also nitrogen gas is made up of two atoms of nitrogen. Now, do you notice something? I have an error again, and that should be nitrogen gas, not oxygen. There are 118 elements, and you find them written in the periodic table of elements. Now take note, it is called periodic table of elements. It's not called periodic table of compounds. Why? Because only elements are found here. But notice that H2, O2, N2, they're not there, but they're still considered element. Why? Because it is made up of one type of atom. Now let's continue further on. An element is represented by a chemical symbol, and the chemical symbol is this one here for hydrogen. It's H. It may be just one letter or two letters, but always the first letter is capitalized. So here's an example of hydrogen. We have H for oxygen, O, just one letter. But we also have helium with two letters, but the first letter is capitalized. And we also have here neon, which is the first letter capitalized. Let's take a look at what we call diatomic molecules, such as hydrogen gas, oxygen gas, nitrogen gas, fluorine gas, and chlorine gas. They are considered elements since they are made up of one type of two same atoms, hence the subscript 2. Now we'll talk about subscript in a few minutes, if not today. We're going to talk about it tomorrow. Now again, let me correct the error. That's going to be N2. Further on, a chemical compound is a combination of two or more different elements that are chemically combined. So now we talk about chemical compound. This also means two or more different atoms combined. And here are some of the examples. Of course, water, H2O. Why is it a compound? It's made up of two different atoms, hydrogen and oxygen. We also have carbon dioxide, you know, the gas that we exhale and plants need. So we've got two elements, two different atoms, carbon and oxygen. We also have salt, and that would be an atom of sodium and an atom of chlorine, and that makes up salt, sodium chloride. We also have glucose. I know in seventh grade you've talked about glucose when you talk about what process? That's right, photosynthesis. So in glucose, you've got three elements, three different atoms, and each of these elements have specific numbers to make up the glucose. Now let's continue. Chemical compound takes on physical and chemical properties different from the individual elements. Now what does this mean? Let's take a look at an example, which is rust or iron oxide, which is a compound made up of iron and oxygen. Once iron and oxygen are combined into iron oxide, the individual iron, which is shiny solid, and oxygen, which is an odorless gas, lose their original properties and take on new ones, thus creating a new compound called rust, which is a fragile, dull, brown-colored solid substance. Let's take a look at the equation. So here is iron. As you can see, iron is a solid gray metal, right? And it is combined with oxygen, and oxygen is a colorless gas. As I said, iron is solid gray metal. So the color property is gray and solid. Oxygen is colorless and it's a gas. But when you combine the two, it's gonna create what we call rust. And take a look at rust. It is dull, it's not shiny, just like iron. It is brown, neither one of them is brown, but rust is brown and it is solid. Now take note, oxygen is a gas. So the property of oxygen and iron are no longer there. Instead, the rust that was formed has different properties. So we say when compounds are made, the new substance takes on a new set of properties. It's basically like these atoms here are just rearranged to form a new substance or a new compound or a new thing, right? But the properties have changed. That is what it means with that first sentence we have on the top. Compounds are represented as chemical formulas. So you have here, of course, our H2O, CO2, and right here we've got NaCl. So these are what you call chemical formulas. What do chemical formula identify? First, it identifies each element making up the compound. And you know which element because of their chemical symbols. You go to the periodic table to check what elements are making up that compound. And then it also identifies the number of atoms of each element, meaning how many atoms make up that element in the compound. And these are in very specific ratio. For example, water will always be H2O, meaning two hydrogen always and one oxygen. If you remember our activity a while ago where we have H2O2, remember the hydrogen peroxide? An addition of one oxygen makes it not water anymore. It has become hydrogen peroxide. Okay? Right here, for carbon dioxide, it will always be one carbon and two oxygen. If there is an additional element, then that is no longer carbon dioxide. In the same way for sodium chloride, it will always be one sodium and one chlorine. That is what we mean when we say a specific ratio. Let's take a look at our iron oxide equation. If you can see here, we have an element here. That's an element, though it has a number, and we'll talk about that number in future lessons, but that is an element. Now, you see here O2, there are also numbers, but that doesn't make them a compound. O2 means two atoms of oxygen, and that is just one type of atom, so that's an element. So two elements combined forms the ferrous oxide or rust, which is F2O3. This is the chemical formula, and this is now a compound. if you see F2O3 and you read up on it, then that is referring always to rust. If that changes to something like this, K or O2, then that's not rust anymore. A chemical formula identifies a substance. A chemical formula identifies a substance. And that, by the way, is one of our pink aids. So that concludes our mini teach on elements, compounds, symbols, and formulas. See you next lesson.